Welcome everyone. Hello Joe.
Hello.
Today it's something new for me because we have a native speaker in English and we will do a presentation with a native speaker. Is it true that in Ireland is native English?
It is, yeah, absolutely.
Okay.
We,
Okay.
yeah. So should I introduce myself or be?
Yeah. I just checked if the stream is starting, and the stream now is started. There's usually a little delay, and maybe I introduce myself. My name is Michael. I'm working for the PM1 as Joseph also did. Do. And maybe you introduce yourself a little bit.
Yeah, so I'm Joe. I'm from Ireland, and I've been working with PM1 since November. So I did a 3-month practicum here, and have now just started as a junior data analyst full time. So back home, I studied physics and maths for my bachelor's degree, and then worked as a strength and conditioning coach in our university with our university clubs. So that was focused on the physical training of the athletes, not so much on the technical side. So everything you do in the gym. Yeah, for football, for rugby, for quite a few sports. So then I moved to Ireland moved to Germany with my German wife, and fell into this this practicum, which suited my skill sets quite well, I think, with a bit of domain knowledge in sports and the analytical skills from soccer, so from physics. And I guess we'll just jump in and take you through our findings.
I will share your screen, and if there are some questions, feel free to insert your comments. Better in English, because if you do it in German, I have to translate it to English. And we will make maybe some mistakes in this one. Therefore,
okay.
Feel free to enter just your comments.
So maybe I just take us through the data first. So we completed this strategic project through the StatsBomb open source dataset. So it's freely available on their GitHub, and it's in the form of JSON files. But once it's extracted, you end up with 8 relational tables, a central event fact table, and 7 dimensions. So I'll just take you through quickly. So we have a competition frame, just tells us what league we're playing in, and the year. The season frame takes us through the year. A lineup frame for every match will give us which players played in a certain match. The tactic frame shows us what position every player played and if there was a change of position where they changed to. The event obviously is the big one, our central fact table, which will give us a lot of detail on every single event that happens per game. I think there's nearly 3.5 million rows in this one individual table. A related table, which will relate every event to another event. So say I pass to Michael, Michael passes to someone else. They'll all be related in a chain. And then a freeze frame, which gives us the player locations for certain events. And then a player features ranked, which we'll get to later. It's one of our creations. So
you built the features for the ranking, right?
Yes. So for a bit of clustering. So we wanted to cluster the players or segment them, and we built these features based off how they play. I can take through that.
Maybe one question: which tool you use to do all the data transformation, to do all the data wrangling?
All in Python. Yeah.
Okay, Python. And where you stored your data? You stored your data in Azure.
Stored data in Azure. Yeah.
Okay. And then you use the Synapse workspace, or what was the workspace you used? So the tools.
It's sports analytics workspace. Yeah.
Okay.
Maybe it's easier. We can go through in Jupyter notebooks as well, just it's visually better. So we go through the EDA process. So we can see here the different distributions of leagues we have, and by far the winner is La Liga, taking up well over 50% of our games. And then of those games, we've got a pretty even distribution of how many games are played in how many seasons, with the exception of the earlier ones. So 2004-2005 season only had 6 games. And then of those games played, Barcelona play in every single La Liga game, and then a couple of Champions League final games. So really what we have is a data set that's skewed towards analyzing Barcelona, which is the direction we took our project in.
So it's a little bit biased.
Yes, quite biased. But it was nice to focus in on one thing. Yeah, so you see these are our event columns. We get a lot of information from the timestamps that an event happens, the location, the type of the type of event, and then subtypes. So there'll be shots, subtype, volley, or a diving header, and then IDs of where that shot came from. So did it come from a corner? Was it from open play? Stuff like this. And then we can just quickly visualize the type of events that we have in our data set. By far with the most is our carries and receipts, and then nearly no referee ball drop. It's like a rare event. And then related, nice and easy, just gives us the ID of one event related to another ID of the related event, and then the index. So this would be the third event in the chain of relations. And then freeze just gives us the XY coordinates of players for certain events, and tactics where each player plays. So let's jump into maybe the more exciting stuff. And I think it's a bit easier to see on Jupyter Notebook, so I might just go there. So we use this MPL Soccer library for certain visualizations, and they give a really nice pitch visualization that we can then use as the background of all our plots, especially when we want to analyze the locations from which events occur. And maybe the most interesting one to analyze, there's lots of different variations of the pitch we can use, is shots. And here we just picked a random game, Barcelona versus Osasuna, and we look at the shot locations from that game. And you can see nearly all of the shots happen from inside the box. So we didn't know it at the time, but we were beginning to find the foundations of our expected goal model that we'll go on and talk about later. And then we can go a little further here and color code successful shots that result in goals and who took them. And we can see that all of Barcelona's goals come from inside the box and from a very wide goal angle. So the goal angle is from where the shooter is standing. If we make a line to the near side post and a line to the far side post, it's that angle in the middle. So being straight onto the goal. So shots close to the goal and with that wide angle, we can tentatively say from this are quite likely to score. And then we can look at maybe all of Barcelona's shots throughout.
So you will say the expected goal is a lot about you know what?
I know. Not geography, geometry.
Geometry, yeah. So you basically say this one is better than this one, and Neo is better than Father.
To bring it, to reduce it down to just 2 factors, and they definitely be the most important, and then going from there, maybe if there's any other players standing in the way. And then we can look at all of their shots throughout the entire data set, and then all of their goals throughout the entire data set. And we can start to say 2 more things about goals. One, they're pretty rare. There's a lot of points here and not a lot of points here. And 2, the points that happen here are predominantly inside the box. Okay, so that positioning is key when you come to score a goal. And then you can see the penalty spot there. Such a great opportunity to score goals from, because you're close and you've got a wide angle and there's nobody in the way. And we could do the same on a heat map. So next we had a look at Voronoi diagrams. So these will divide the, scroll down a little more, the pitch into so-called zones of control. Okay, so the places of the pitch closest to here, the Barcelona player in red will be shaded in red, and to the Osasuna players will be in blue. And we can look at these ideally as a time series to see how maybe good attacking teams or good defending teams can close down the space controlled by other players. So this was a Messi goal. Messi the player, not Messi as in untidy. But the ball came here from this outside winger in a lot of space into Messi, who's tucked in behind these four Osasuna defenders to score. So thinking of space, we started looking at the areas through which players are active. So we next turned to convex hulls. So these will just draw the boundaries of a set of events. So this is Messi's shooting events from that same Osasuna game. And we can see where he shoots from inside the box with a wide angle to that goal. And quite interesting, you can think about what makes Messi a great shooter. Is he great because he can score goals no one else can score? Or is he really good because he gets into positions that he's more likely to score from? And then we thought of comparing convex hulls of two players. So here we compare Messi in this game to Dani Alves. And you can see first Messi has no discernible position. He's everywhere. He really plays as that false floating midfield, whereas Dani Alves sticks to his right flank, but he plays as a back. So he plays very aggressively for a defensive player, really pushing into the opponent's half and really having more events in their half than he has in his own half. So we thought, well, what about a game where Barcelona don't win? Because they won this game, I think 6-1 or 7-1. So we looked at a game where they lose. And we look at here Dani Alves in his winning game, his convex hull, and his convex hull in a game where he loses. And you can see the complete change and how it's changed his play style. But also, and I'll come into it when we have a look at their pass networks, how his inability to get forward could have stopped Barcelona scoring. So maybe I'll talk about this. So for visualizing passes, if we just visualize the end X and Y locations, we end up with a mess. So it's very hard to get any information from this. So we need to look at it through some context, because passes and maybe poorly evaluating passes has had some negative effects in soccer in the past. One of the first attempts to evaluate a soccer game, a coach saw that his team, or most goals occur before 3 passes. So the logical thought process, I should minimize the amount of passes my players take to maximize the goals, which gave birth to this long ball game, where as soon as the player gets the ball, he tries to play it long into the box to score. So
he's the English kick and rush. Kick and rush, so kick it.
Yeah, kind of, but it's completely confused correlation and causation.
Okay.
And isn't effective, and really held sort of early analytics in soccer back. So if we look at pass networks, so here we're looking at the position of each dot is the average position from which a player makes their pass. Here, RB is right back, so Dani Alves, and right center forward, Messi. So the average position from which they make passes. And this connection, the thickness of the connection denotes how frequently they're passing to each other. So we can start to see.
This is about a whole game, or is this multiple games?
This is throughout an entire game, just one game.
Okay.
So it'll change for formations throughout the game if they do.
This would say the most frequent pass is Dani Alves passing from the right in the middle.
From the right to Messi, yeah.
Yeah, okay.
So you can see their great synergy. So I'll backtrack a little, and we can see Dani Alves here in that game making most of his passes from this location to Messi, who's going to score, versus the game where they couldn't keep up and they couldn't score is a game where Dani Alves spent almost no time in the opponent's half. So here, just from looking through the pass network, we can kind of see how if Dani Alves isn't able to get into that sort of deep into the right flank to pass into Messi, Messi isn't able to score goals. So Barcelona isn't able to score goals. Yeah, what else? And then from our player ranking, we looked at PISA plots, so to visualize the different ranks of players. So we made 13 features over 4 aspects of the game, attacking, passing, defending, and possession. So we ranked players based on how many shots they take in a game versus how many goals they take in a game and how accurate are their shots. So there's no point taking 20 shots a game if you miss all of them. How frequently they're passing, how dominant are they in certain aspects of the defensive games, in tackles, in aerials, in pressure events. And then in possession, how far do they carry the ball? So here we just looked at the positive. So if we think of the X coordinate between my goal and the opposing goals, how far of a positive X distance do they carry? So how far up the field can they progress the ball? And you can see Dani Alves does it really well here. Successful dribbles, how many players are they beating? So in this definition, in this data set, a dribble is me carrying the ball around you, so beating the defender. And then what percentage of their dribble attempts are successful. All right. So yeah, from there, I guess we'll jump over to our dashboard. So from those visualizations, we made this dashboard detailing 2 sort of aspects. We looked at club level analysis and then player level analysis. So here, looking at the club win-loss performance, we can pick our club. We're going to stay with Barcelona because we've really only got data points from Barcelona. Look at the split between their home wins and their away wins, and you can see there's quite a drastic change between their win rate, home and away. And then and same with draws and losses. And then quite interesting, looking at their performance throughout a season. And here we didn't just look at their wins and losses in that season. We looked at the goals they're scoring and conceding per match on average. And this data set really details the height of Barcelona. So the last sort of 15 years of Barcelona, not counting the last 5, where they were on top when they had Messi, when they had Neymar. So they did really well here. They weren't conceding and they were scoring lots of goals, but you can see the downward spiral that brings them to where they are today, not as the dominant force in La Liga. And then we looked at we started thinking of who are Barcelona's biggest threats when they play home and away. So we started looking at the goal split. So how many goals do they score versus how many goals do we, Barcelona, score at a home game and an away game? So here, when we play Real Betis at home, they scored 15 goals throughout all seasons, and we scored 38. So we can kind of track who are our biggest rivals or who is it most dangerous to play against. Okay, and then from the same vein, we looked at managers and how does a manager influence a team. So we can maybe pick Josep, just because it sounds like me, and look at his stats through his tenure as manager of Barcelona, and see he was pretty dominant in his win-loss, and also other aspects. So his XG per game, so his his player's ability to make good quality shots throughout a game. And then certain KPIs we started to look at under a manager. So how many shots, how many passes, how many assists are players making under a manager on average per game? So then when we look at different managers, we can compare the two to see which players really thrived under a certain manager. And then we'll jump into the set pieces. So here, looking at corners, we can see how many corners in a certain season. We're on 17, 18 here. Oh, it's nice and slow. So this is a Python visual. Why it didn't update so quick, but we had to make our own pitch here. Power BI doesn't, in its cloud, its service form, we can't run every package we want. So we had to take a step back from MPL soccer and make our own, which is a fun process. So here we can look at the successful passes in blue and the unsuccessful passes in green, gray shooting opportunities, and red goals that Barcelona make in a season. We can filter by high grounded low passes, and then by player who's taking the pass. And you can see from 186 corners, they only got off 29 shots, which is not so bad. Okay, free kicks was the next set piece we analyzed. Here we just broke it down into free kicks that end up in a shot or free kicks that end up in a pass. And you can see Messi makes pretty much all of their shots from free kicks. And he's got a pretty good success rate out of 47. We'll have a look there. 0-0. Yeah, 47 free kicks, 6 goals. So making all of Barcelona's goals from free kicks. Throw-ins, not so exciting. But yeah, definitely a part of the game. And you can just visualize the start and end point of all throw-ins. And if we want, we can pick a certain match and have a look at the throw-ins from that one game. Okay.
But a really interesting thing, what is defined as a failure when you talk about throw-ins? If something is going to the opponent, or what is the failure?
If they intercept. And then, I mean, we look at shot assists from throw-ins, where the throw-in is a direct assist to the shot, and we get 1 throughout a whole season. So maybe not the most, in of itself, the most important.
Is there also counted headers? If you throw in and headers counting?
Yeah, okay. But I mean, maybe one thing, if I pop back to corners and I go to the next season. Yeah, so Barcelona are not the best team at scoring from their head, and you can see this from their corners. I mean, when you have a weapon like Messi, why bother? So first, you can see almost half of their corners end up in this short tap out to a player at the side, and of the ones they do play in high to the box, they only got 1 goal from an entire season's worth of corners. So 1 goal in 191 attempts isn't so great. Yeah, so expected goals. And so here, maybe we'll say the expected goal is the script runtime error. Great. Jump back to desktop. So expected goals is the probability that a goal will be scored from a certain shot. So from that way, we can assign some sort of value to a shooting opportunity, and we can start to visualize where on the pitch these high values.
Maybe Power BI is not the best tool for this, but
yeah. Yes.
But one question: what is the main feature, or what is the main impact for expected goals?
So it's first distance to goal is number
Okay.
one, and second is this goal angle. Okay. And then interestingly, we got the best results when we put back in the X location. So it's linear distance from the opponent's goal. But those two are definitely the most important. And from there, maybe we're almost done. I'll jump back to our model. So we look at the model. So we did a classification model for the goals. So we attempted to classify whether each shot was just miss or goal. And here are our features. So we took the distance to goal, its shot angle. We later encoded the body part ID. So whether it was a shot from the foot or a shot from a head. Obviously, a header from 20 meters is a lot less likely to be scored than a volley from 20 meters. The technique, so that was a shot from the stationary, from the floor, on the volley, a diving header, a regular header. The play pattern ID, so was it regular time? Was it a free kick? Was it from a corner? Shot one-on-one, so just a binary. Was it just the shooter versus the keeper? Shot open goal, was the keeper out of the equation and all the shooter had to do was hit the target? And under pressure, was there a defender closing down our shooter? So I think in the end we applied 6 different classification models to this. And I haven't run it, have I? Yeah, so we were actually pretty accurate, I think, with our results in that we were very good at predicting misses, not so great at predicting goals, which we laugh. But it's actually, I think it says a lot about goals as an event in themselves. They are very unlikely.
Okay. So if you are now starting sports betting, we should always bet on no goal in the next 1 hour or something like this.
Yes, yeah. I think our decision tree model was the most accurate. So we had an accuracy of 89% in that model. So 89% of our predictions were correct, which sounds great. I definitely would have taken that as a final score in my undergrad. But when you look at the percentage of total shots that end up in a miss, it's 88. So we're only 1% better than a model that predicts everything as a miss. Yeah. So
So you're saying it's pretty hard to predict goals.
It's very hard to predict goals, but I think the value doesn't come. Yeah, we can see it here. The value isn't from this binary. That's going to be a goal. That's going to be a miss. The value comes from this figure, this probability that we think that will be a goal, that we can then evaluate a player's decision making or how threatening a certain team is.
Okay, so basically you're also saying that because there are 2 less events of players scoring goals, you can't say, okay, because this player is in this position, his likelihood is so much higher than another player.
Yeah, so we didn't put in the player ID, so we assume all players are the same. So we're going to get some error from that, but the benefit is we then have a much bigger data set with which to train from. But what's really interesting is when you look at players that outperform their XG model, so Messi, Ronaldo, they outperform it because the model isn't taking into account that they're the best striker in the world or what have you, but they don't outperform it by a huge amount. So really what makes them better isn't that they can do things that no one else can. It's that they end up in better positions to shoot from, if that makes sense. So they're better at maximizing the XG of shots they take.
Okay, so you're saying if an average player and Messi and Ronaldo are in the same spot, the expected value of Messi or Ronaldo is higher than the expected value of the average player. in the same sport?
Yes, if we had, well, from the models we have, they don't look at the players, so they'll all be the same. But if we, yes, obviously Messi will get more goals of the, say, if we could give them all the same shots, they'd get more. But from open play, just looking at how they take their shots, they don't score more because they can score shots no one else can. They score more because they take shots from better XG locations. If that makes sense.
Yes. If someone has a question on this, please just write a comment. I will bring you up.
Obviously, they probably can. They are more accurate and all the rest, but not to the degree that I think we think. That they're a complete wizard.
So because I would say because the competition is so close in La Liga or Germany or in Great Britain, that just a little bit above average shows that you are really a high outperformer.
Oh, absolutely. Yeah.
Okay.
I think. Sorry, I'm going back to my strength and conditioning days, but I think on average for the real power events in the Olympics, so the 100-meter sprint, the difference between first place and fourth place is usually between 1% and 2%. So the difference between a gold medal and nothing is that 1%. No.
Excepting your Usain Bolt.
Yeah, maybe that's one outlier. So maybe I pop up. I can show a potential use cases.
But this is quite interesting because of the narrow ranges between average and above average and really, really exceptional. Because the ranges are so narrow, it's really, really hard to predict because your mistakes will going up.
Yes, it's hard to predict, but and I guess this is where the value of the XG comes in. It's not looking at the one individual shot. It's maybe looking at a player's shooting performance over several games or a whole season, because eventually we're going to trend towards the average. So maybe Messi has an off season, he doesn't score any goals, but we look at the sum total of the XG he made from the season, and we say, okay, he didn't get any goals, but if he keeps playing as he did through our XG model, on average, he is going to get this many goals. And other
your model is not able to predict the next Messi because you see one player's outperforming is XG. You can't predict the next Messi or Ronaldo in an offensive spot.
I think you can maybe not predict him, but you can definitely predict players that play like him.
Okay.
And maybe this is a good segue into our player clustering.
Oh, cool.
So maybe we'll take Messi as an example of this kind of rags to riches story of a player coming out of nowhere to dominate football. And there's got to be more like him out there somewhere who displayed the same qualities that he displayed as a youth athlete. And we're just not able to find them because you can't have a scout at every game, at every kid's game throughout the world. But maybe you can if you start collecting data from every game and analyzing that data. So what we did was previously we went through our 13 features and we used them as the basis for player segmentation. So we did this twice, once through a principal component analysis and once through a uniform manifold approximation. So 2-dimension reduction. So we took all these 13 features, reduced them down to just 2, and plotted them so we can see where players fall. I'll bring you down to the nice visual. So this is our first. These are all the players in these 3 segments. This is our PCA component analysis. And the nice one, our UMAP. Maybe this is really zoomed in. So we can start to say, okay, so maybe Messi lies here. Okay, and I've got data for every player in the world. and I can look at players who fall close to Messi in this segmentation. So I can try and find players who should play like Messi, but maybe I can find the player who's playing like Messi plays, and he's only 17, or he's only worth 1/5 of what Messi is worth, and use that as the basis to start either creating my junior team or to build my professional team, which is a lot like the basis of the Moneyball movie, or Billy Beane and the Oakland Athletics, trying to look at how we evaluate players, through what metrics we evaluate them.
But I guess this is easier for sports like baseball than a sport like football, but because as you have shown with the passes, there can be 20 passes, then a shot. In baseball, you have separated actions.
Yes, it is, and that's definitely one of the things that held back analytics in soccer, at least initially. So when it started, people, before computer vision, before GPS, we would only collect data on events. So you'd only have a data point for the person who was in possession of the ball. And a player is only in possession for, I think, about 3 minutes a game, for a 90-minute game. So you don't get a lot of data per player. Sorry, I kind of went off on a tangent there. But yeah, it's hard to segment the game and to see the root cause of maybe where that goal came from, as these chains of plays can be quite long.
But the funniest thing, you say a player is only in 3 minutes of a 90-minute game in possession of a ball.
In possession, yeah.
And he should run. Should run somehow the other time. So this was let's assume that it's more important to play in the right places than to be good at ball.
And, play in the right places, to position yourself in the places with the higher expected goals. So when the ball comes to you, you're more likely to score that goal. But yeah, I mean, in our data set, we just got a freeze frame for certain events.
Yeah.
But what would be really interesting is to work with GPS data. So we have a constant time series of the positions or the position of players throughout a game. Because I think that's the key, is how a player moves when they're not on the ball.
Okay.
All right. So maybe I'll show you this kind of an interesting use of XG. So this was a Champions League final between Bayern Munich and Chelsea. And
I can remember. It was painful.
Can you remember?
Yeah. I can remember.
Okay, I was hoping you could. Okay, but maybe for anybody watching. Okay, so if you're looking, each red dot here on the pitch is a shot. So these are all of Barcelona's shots, and these are all of
Bayern
Chelsea's.
Munich.
Sorry, yeah, Bayern Munich's shots. And the size of the dot is proportionate to the expected goal. So the bigger the dot, the better the shooting opportunity. And when you look at this, you think, wow, Bayern Munich are definitely should have won here. They had far better shooting opportunities and far more. And when you add them all up, Bayern Munich ends up with this XG of 3.4. So if we kept playing this game a million times, on average, we'd expect Bayern Munich to get 3.4 goals and Chelsea to get 0.28. But as maybe you can say, Michael, what happened was a 1-1 draw, which went to penalties, and Chelsea won on penalties. So if this game was to happen again, even though Chelsea won, the smart money would be to bet on Bayern Munich. And the Bayern Munich coaches shouldn't be too crushed, because by rights, if we played this game a million more times, they're going to win more times than not. And it's Chelsea who should really be reevaluating how they play after this game and looking for ways they can improve. And maybe the second case, like we talked about, players having off and on seasons, is, say we need to buy a striker. We have 2 strikers, and in the past season, we'll say striker A scored 10 goals and striker B scored 7. So striker A is probably more expensive. More clubs are going to be searching after him. When we look at the XG of those shots, player A had a lower XG and player B had a higher. So we'd expect on average, because we're just looking at one season here, player B will outperform player A in the long term. So really the smart money would be on player B. Hopefully I've explained this well, which was the model that Brentford used, and they've been called the Moneyball team of the Premier League. This model brought them into the Premier League, up from the division, and they've had pretty good success on quite a limited budget. Yeah. Okay.
Cool. You can show the dynamic pizza plot in Power BI, because this is a cool thing to compare players.
I'll do it on the desktop. It might be a little quicker.
Okay. Yeah, so this is the downside of using Python visuals. They're not the fastest in Power BI. So.
Okay, yeah. So here we can compare Neymar to Messi, the two great rivals. Neymar wanted more time in Barcelona, but as the main striker, but was getting overshadowed by Messi. Then left for PSG Paris, and then Messi came with him a few years later, which I find the irony quite funny. But yeah, does anyone want to type into the chat a Barcelona player and we'll have a look at his pizza maybe? Or Michael, if you want to shout out a name, we can search for a player.
Per Stegen.
Oh my.
It's a goalkeeper. Ter. Nee, Ter, not Per, Ter. Or Stegen, you can...
Okay, maybe not.
Okay, they don't have goalkeepers. Now we know it.
Yeah, I expect a 0 rank for shooting and goal scoring.
Suarez. So you're testing my football knowledge about Barcelona.
You're also testing my spelling. SU? How do we spell Suarez?
Barcelona. These are the funny guys here. We ask for Barcelona players and they say Lewandowski. Maybe they know something we don't know.
LEW? Ah, here we go.
Oh, yeah, but he will be only in some place because there are not a lot of data about him.
Yeah, we're only going to get...
it's a little bit hard to compare.
Yeah. But ranking quite high from the shots. But yeah, so this falls down. So say in our data set, he only plays one game. So maybe he got 0 goals from that one game. So that's why he's getting such a low rank. But then you can look at his shots. I mean, he must be quite a good striker because he's ranking in the 97th percentile. I don't know this guy, so maybe this shows my knowledge.
So,
but maybe interestingly would be if we could add another slice here that shows his average expected goals per game.
Okay.
You know, because that still would be quite high.
Yeah, I guess this is a really cool thing to say. Average expected goals per game is a really cool thing also to compare. But the problem is with the model, you're going for offense. There is no real prediction for the value of the defense.
Yes. Yeah. So I started. I didn't finish it, so I can't demo it. But this looking into Markov chains. So really, our expected goal only evaluates these shot events. So an event that definitely happened, but we don't really have a nice way to evaluate and to like associate maybe a comparative value to the events that led up to that shot. Okay, so say I pass to you and you score a belter from the halfway line, and I pass to someone on the edge of the box and they score. Yeah. I get a pass assist for both of those. But I mean, do I really deserve an equal assist for both of those shots?
Yeah.
So we looked at how does my action progress the XG of the next shot, or if the person was to shoot from where it came. And then we can also turn that on its head and look at a defender. So how does their action minimize the XG of the opponent?
Okay, you can call it expected obstacle value.
Expected obstacle. Expected, because we're expecting a shot.
Okay.
No. But no, that's quite interesting, I think, as a next use case or the next metric.
Yeah, very, very cool. So thank you for presenting this. So do you have final words? If not, someone else maybe has some question. We are open.
I hope so.
I guess everyone is pretty much shocked how many statistics you can do with football.
You can do so much
outside the normal statistics you see on Sky.
yeah.
But to be honest, I've watched football the last years, I would say in a normal way, and there are more and more statistics, more and more advanced statistics coming into the normal TV live event.
Mm-hmm.
So they bring in more, I would say, like expected goal or something like this you will see in a normal foot, or like some areas or heat maps. So this is something, is getting more and more interest in football.
Yeah, and why not? Like, I think it definitely has its place. We can get some really good insights into like how teams play, where their goals are coming from, and to compare individual players. I think it's not going away anytime soon. There's a good, if you want to go down the YouTube rabbit hole, a Scottish pundit kind of loses his temper. I think it might be Bayern Munich again. They lose in the semi-final in the Champions League, and his co-presenter brings up the XG, and he's trying to say that, but they didn't do so bad. They actually got a high XG, and he goes off and really gives out to him. And I think he calls it nerd nonsense. They expected goals, but it's definitely here to stay, I think, and it really does give value.
Cool. So no one has question. I would say we can finish the session.
Okay, cool. Thank you for having me.
Thank you very much. It was a pleasure. It was really, really cool. And I know nothing about football.
I know. Yeah, it's the beginning of that Kruger curve. Don't worry.
Yeah, before I thought I'm an expert in everything about football, and now I'm thinking I think it's a good task for all the amateur trainers to say, I can do so much more with football data.
Yeah.
So the last words are on you.
The last words are on me. Well, I mean, what was the quote that our marketing team led with the first blog post with, that soccer's a game of two sides in 90 minutes, and in the end, Germany wins. I think I'll leave with that one.
Good.
Okay.
But he was from England.
Yes, he was an English coach, which is even more fitting, I think.
I guess he was, at the time we said the season, was not an English coach. He was a player, lost a semi-final in the World Championship 1990, Gary Lineker.
Okay.
I guess it was his quote.
Yeah.
So who knows the quote? Who can write? Who was it? Goodbye.
Ciao.